Hello everyone. In this video we're going to look at behavioral programming. This is the formal method that's at the basis of Provengo's tool suite. It allows us to do all kind of modeling of expected system behavior and analyze it and visualize it, do all kind of stuff with it. It's also very intuitive and engineer friendly. Also importantly, there are many features for Provengo. There's a lot of cool stuff there. This video is about the basics. You can see all the cool stuff on our documentation and website and YouTube channel and street performances and stuff like that. This video is the basics, right? The basic theoretic stuff going up. So, behavioral programming. Basically, motivation is to generate complex system behavior using multiple systems, simple behaviors that are easier to maintain and reasonable. It enables visualization, validation, verification. Basically, it's an auto-composing, correct by construction, large state machine that are also verifiable and easy to maintain. Also, if you're a former student or someone from that exact area of formal method, then yes, technically it's a transition system, but this is a publicly consumable video, so they're kind of the same. So it's a state machine. Each simple behavior is called a B thread. Now, B threads communicate through a simple event-based synchronization protocol. How simple? Very simple. And synchronize, they can request events, wait for events, or block events. And when they all synchronize together, what happens is that the system itself looks at all these synchronization statements and selects an event that was requested and was not blocked. And that's it. That's enough for creating what we need. So let's do an example. Provengo, create, we want to create, and an example sounds like an appropriate name. So we have this little wizard here. Yes, I want to do this. Sure, I delete ignore file. Yeah, there's also a GitHub Copilot thingy. We do so. Also create that. Okay. Let's look at this an example thing. So what we see here is just a regular VS Code, but it has Provengo's IDE installed. It's publicly available on the VS Code market site. Various panels which we will not look into at this point, but what we are going to look at is the specification. Let's start with the specification. So, okay, so let's do a simple hello world thread. Okay, so I'm going to create a new B thread, hello world, and we're going to request events that will reflect this hello worldness thingy, right? So request event hello. Gonna need 4 events here just so we'll have better understanding of what's happening. So hello world and what's up. It's very important when you query a planet's state, to say hello, try to be interested. I'm told. So I can run this now, and okay, not very surprisingly, we get this hello world, what's up. Perhaps a bit more surprisingly, I can analyze this and get the state machine, or a drawing of the state machine. I mean, obviously the important stuff is the data structure underlying the state machine, right? This is what we analyze and validate and do stuff, but it's very good to visualize it as well. just to be easier for us and also to show off the config stuff, I can also do say specify an output format for GraphViz and do a horizontal layout, and this will allow us to create nicer visualizations for this video, and also a bit more interactive. Okay, so this is the basics. Now let's add another bithread. I would have added it myself, but I'm gonna let Claude do this. Add another bithread, greeting the world, but in a friendlier way. Let's see what it can come up with. Okay, that is yeah, I know what it is. Good. Thank you, nice model. Okay, so well, first of all, as you can see, it's very easy for Gen AIs to do this type of thing because it's very aligned. Bithreads, as I said, are very simple and they're very aligned with a single requirement, or like they're normally something it would be easy to say in a sentence or a prompt. So good work here. Hi there, beautiful world. Hope you're having a wonderful day. Yeah, okay. Let me join our model with this hope, and as we analyze this, now what we can see here is basically two threads freely interweaving, right? So each execution is basically starts here, and if we were to advance just the first and then the second, it would be this, right? Hello world, what's up? And then hi there, beautiful world, hope you're having a wonderful day. So first thread goes here and second thread goes here. Okay, but then obviously you can also mix stuff. So let's start doing all kind of blocking and stuff like that. So suppose I want to give the hello world thread a advantage, right? So I can say hello world first. We're going to say function we're going to create a single synchronization, and here we're going to wait for event hello, no, world. Let's wait for world here, and while we're waiting for the world, we're going to block event, going to local this guy, right? Hi there. Okay, so what is basically going to happen is that hi there, this event here or here will not happen until world happens. So we're going to basically remove part of the possible execution space. Analyze this, and you see that a lot of the execution space has been removed. Okay, another thing we can do is do all kind of verifications on this. So for example, let's say I don't like this thing here. This, the idea that up and is followed by beautiful world. That's for some reason not good for us. So we can add another bithread. Again, this is the basics, right? There's a lot of DSLs around this, but this one's the basics. This one is the basics. So no world after up or something like this. Function. I'm going to wait for up, and then I'm waiting for and if this happens, I'm going to be very upset and say halt. No, beautiful world after up. Okay, so this is just another bithread, right? I'm adding it, and if we're to analyze this, you see that it actually detected, the Provengo actually detected the violation of the rule we added, and it can also tells us which traces lead to this violation. So we can take it back to the people who did the algorithm or did the product and tell them you're actually breaching or you allow something that shouldn't be allowed. Okay, so this is not a bug in the system, it's a bug in the requirements, basically. So these are the basics. There's some slight DSLs around it. So I'm going to show the basic one. For example, if you want to choose various greetings, right? So not just hello. So you can say select greeting from hello, hi, and I don't know, hola. Okay. So I'm adding this. This is an example of a DSL. Basically, it's just requesting events, right? But we add some metadata and stuff like that, so we can do proper analysis after this. And as you can see, now we have hello, hi, and hola, and we actually say this. And again, this is the metadata, right? So we can actually add some pretty rich metadata over events out of the scope of this video. We also can greet multiple planets, right? So select planet from world, Mars, and Venus, right? Again, no need to, we can generalize over planets, right? It's just, okay, so now we have this, basically we have all the options times all the options, right? So Cartesian product. And if I was to run this for a second, we'll have now, for example, hi world, what's up? Okay, suppose I don't like to say hi to the world. Suppose I think once, we chose hi, I don't know, we don't want to greet the world. So I can add another DSL constraints, and I'm saying, well, after select event greeting and hi, what I want to do is block, so this is another DSL obviously, right? Select event world. Right, you are right, thank you. Planet world, and I want this blockage to stay until event what's. Okay, so I'm basically creating this after block until statement, and what it does is it's going to see if we're selecting high, then it will prevent the world from being selected until what's this event is happening. If I analyze this, Provengo detected the fact that hola and hello act basically the same, right? They basically get to the same point, then they can greet each planet, right? And what's up. Whereas if we choose hi, then we can't greet the world, right? World is here, but it's not here. It's not here. And so we can only do Mars and Venus. And this is an example of a correct by construction system. So this was basic intro to behavioral programming. As I said, in Provengo we have a lot of DSLs over to have graphic stuff. We can do test suite out of it. We can implement systems. a lot of things you can do just based on creation of this type of models. And we'll look at this obviously in future videos. Thank you.